Anyway, when you look at the planet through a telescope, you should see a lot of features on it, and not on Saturn, but a lot on Jupiter. On Saturn, you'll definitely see the rings almost like this, and you might see a belt or two in the polar cap, but it takes a good time of seeing anything else like these other stuff. So it's sort of a bland planet when you look at it, except the rings make it, and the equatorial belt makes it and stuff like that. But the rest is mainly bland except for dimmer polar cap. This might be something more of a yellowish color, and every once in a while there might be an eruption or it might be a belt on there, but it's kind of rare. It rotates around in its orbit in 29.5 years, and you can see the ring tilting in different ways. That's because the orientation in its orbit is 29 degrees tilted, and when we're in this position, you see something like this. Well, it's way over here. Where is it? It doesn't put it on there.
Oh, the arrow.
Yeah, not the arrow to that one.
Yeah, there is one for that then.
I don't see them, there's one. But that would be something like this, I believe. No, that's not it. Be over in this area right here.
Right there where
Right
the
there.
Earth is right between the sun and Jupiter and the ringer edge on. That's
Right
the
there,
picture of
the other edges. That's where they're going, the other edges. And then when over here, see it's upper, high, and lower. This is what a lot of people are talking about, the hexagon. It's a large jet stream up there in the polar region, and a central vortex right there. There's a lot of clouds in there, different wavelength than the visual wavelength. Here you can see it more in detail. What you're seeing here are all individual clouds that form and dissipate in the circular motion of the vortex and the jet stream right up here. And outside of that, you have more of them there. And then you get to another belt down here, which is moving much faster around the planet. Colorization helps you show things. Again, this is just the shadow of the rings on the planet right there. You can see here how major storms form in there and dissipate over time. When you look at Saturn, it has a whole family of moons around it and those rings. The rings that we can see in Earth are a dark outer A ring, a brighter B ring, a dusty C ring. The D ring is very tenuous, you can hardly see it. They find it with the spacecraft, and a couple of outer rings that were also found during the Cassini missions and the Galilei, bypass missions of the satellite. That was the Pioneer and the Voyager, I think. Too many of them. I know which one in order, but I can't remember all the names once in a while. Anyway, the major ones that you would see in this telescope, you would see these moons if you had really good eyesight. Usually you get to see this outer one. Last time I was up here, I saw both of these, this one and the major moon right there, and I have to just, these are difficult to see when the ring tilt is almost at its maximum because the rings outshine them. And they're very close to the rings and it outshines them very much. I used to see them when the rings were edge on or going to edge on with that large telescope out there. Not yet, particles. But the major rings that we see with telescopes is this. This is the A ring, this B ring, and C ring. And there's a lot more detail in each one of these than we see visually from the Earth. In fact, in here, you see, this is Cassini's division. To us, it's a big, dark area void of nothing, everything. Actually, there's a lot of material in here. It's finer, and we can hardly see it. You can see it right here. There's more rings right in that Cassini division. All this stuff is in Cassini's division right here. And there's gaps, gap, 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 and all this is material, fine material going through it. And they all have names. They're small. You pick them up with the spacecraft. Yeah, it's not that kind of. And here we have that F ring right here and two of the shepherding moons right there, Prometheus and Janus. And there's Janus. Janus is interesting because in 1966, before we had this spacecraft and going at the planets, that moon was picked up a number of different times, and they thought it was two different moons. And they couldn't figure out the orbit and so forth. But now they know there's only one moon and not three moons that they thought there was. So I got the name the first time, Janus and Pandora. And there's Pan. Pan is a very, very small moon and a very small empty gap right here. And it looks like that in the photograph because it's overexposed, but that's what it looks like after they act closer and closer. Very, very small moon. It's there. Interesting. A lot of scientists will love this because they want, they say, hey, it's an area where it's clearing material out, but there's still material in here. There's a very fine ring right there inside that empty space. Compared to that, of course, Mammoth is very interesting. It has the large crater Herschel with a big central peak, and the first pictures of it showed it on the side view. It looked like the Death Star. They pulled the Death Star. There it is. There you go. The Death Star. And that's the back side. And there it is in a better picture of it right there. You see right here that little white spot right there. It's just getting the sunlight, and that's a little area right now that we're looking at. Pocket film. This is the most interesting moon with the jets. Installed this. They picked it up later in the mission, and they figured it out, and this is what's causing the G ring. Here's all that infrared shot of all the water vapor coming off, and other minerals and chemicals coming from the north south pole of the planet. And it's coming from this area up here, in the tiger stripe. Oh, that's tiger stripes right here. Yeah, right around here. This is way overexposed. And it shows you an idea of the heat coming from this vent right here. This is all that's coming from these vents. Some are active, some are old and not active. But you can see the temperature increases as you get near these canyons and vent-like features. And this is some of them close up. And if you look at the side view, they're active 99% of the time. Maybe not all of them at once at the same time. We don't know if some shut down, some come back, because they don't have the spacecraft there anymore. They flew through them a few times, and I'll show you all that stuff. Really nice images here, where you can see the unlit portion right here, and see the vents coming up from here, and out there in the lit right there. And the most interesting one that they were focusing on the first message, the image was Titan. Because Titan is the largest, a large moon of the solar system, and it does have an atmosphere. And we know that because wherever you look at it, we see it as an orange hue through our larger professional telescopes and the Hubble Space Telescope. And this was taken with a special filter that will peer through the clouds and gives a look underneath here. And here we have dark material and brighter material, and this is just a haze around it at the edges, because as you get toward the edges, you can't get any detail relief. This is taken with a telescope on Earth. And it matches very well with the spacecraft images with the same type of filter peering through the clouds of Titan on the surface. And there's large maps on there. You can see all these are blocky features because of the resolution that they had at the distance they were taking them. So some of the stuff is bad resolution, some of it's pretty good. And it really varies between the distance away the spacecraft is to the moon. Now, the spacecraft was not orbiting the moon. The spacecraft was orbiting Saturn, and therefore you had to wait a couple of months in order for the alignment of the spacecraft and the moon Titan to come into right alignment so they can photograph images all the time. And they sort of try to pick the orbits because they have small rockets on there to alter the spacecraft's trajectory and path a little bit at a time to get it to closer to this moon right here. This is what they were interested in. A lot of this stuff is interesting. There are cloud tops in the northern and some, but it landed on the surface, and you can see the true color image if you're on there, true color to our eyes. If you're on there, it's sort of a hazy area, but if you enhance the color and change the black and white, you see it. This shows you, by the way, a couple of centimeters or inches from the camera all the way up to the horizon. So it's kind of a weird way of looking at it. And you can see the differences. And these are small little boulders, but they're not really boulders. They're more like an ice boulder than here on the planet. And it's not rock, it's ice, heavy rock, and some rocks, but mostly heavy ice covered material. It has a very interesting interior, which I won't finish. But the atmosphere is very interesting when you come down through it. The temperature starts cold and comes up, and then you get through here, and then down here. The temperature really has you get this condensation haze up on the top, clouds up here with different methane and carbon, hydrogen combinations, really, really bad stuff to breathe. And the, at the bottom, you have lakes of methane and fogs and so forth going on during the summer areas when this is, and you're, as far as facing towards the summer area. After a while, this sort of goes away and settles down, and the summer will be in the other hemisphere.